When a triangle has no right angle in it, to find the area of it is found using this particular formula. And you could use this formula if it was 90 degrees as well, but this is the one where if this angle happened to be something else, let's say 89 degrees, for example, then to find this area, you'd use this formula. And if I said that this length happened to be 3 and this length happened to be 4, then the area would be a half 3 times 4 sine 89, which you would type into a calculator, but make sure you're in degree mode. But why is it this formula? That's found looking at this particular triangle. Now, if you drew a line from B, I just chose B as a random point. I could have chosen any point, and I drew a perpendicular line all the way down to the line AC, where this is a right angle. The reason I draw that line is because I can find areas of right angled triangles really easily. It's just half base times height. So that's the reason I've drawn that line. But how do I find the length of this dotted line? If I look at the triangle at the top like this, that's a right angled triangle, and I can find this dotted line using basic trigonometry, where this is the hypotenuse and this is the opposite. And I would use sine to find the opposite here, and the formula for that is sine theta equals O over H. And therefore, to find O would be the hypotenuse times sine theta, sorry. And the hypotenuse was A, and O is the length, which I'll call P, I guess, for perpendicular, P. And that sine theta, well, theta is still theta, so sine theta. So I know that the length here, P, is A sine theta, and this is going to be useful in trying to find the area of the triangle. But the area of the triangle we know is just a half base times height. And the base, if I took the base as the length AC, that would be B. And the height is the length P I just worked out, which is A sine theta. And by getting rid of the brackets and switching things around, that's a half AB sine theta. So that's the reason that formula exists. Now, for these shapes, to find the volume of a pyramid, A is the area of the base, and it doesn't have to be a square, it could be a triangle or even a circle. If it's a circle, it still works. So whatever the base area is, you multiply that by a third of the height. And the reason you do that is because if you were to make the pyramid's top point over here instead, and you draw all the points to the vertices here, there you could use three of these pyramids. There's the yellow one. Let's do the blue one up here. Let's say the blue one has the base. Oops. The blue one with a base like this, let's say, and that joins to that point as well. And you may be able to see that the blue pyramid is sort of fits here, and therefore makes this whole surface here full. And then a third one is going to be a bit difficult to visualize. A third one you could put at the back with the back face there being the square. And essentially what I'm saying is you can fit three pyramids together. You've got a yellow one and a blue one and a green one all fitting together to make a cuboid. And if you then divided that by 3, you'd get the area of one pyramid, and that's why you have a third of that here. And from what I said before, is a third of the base area times the height. Well, the base area in this case is pi r squared, and so that bit there is effectively A. It's still a third AH, but using a circle instead of a square or a rectangle. And the volume of the sphere is 4/3 pi r cubed. And this one can be, there's a really good YouTube video explaining why this formula works, and it's very difficult to explain on this video. I'd suggest you search YouTube here. for why that's the case. It's quite an interesting video.